So in part B, they now ask you to express this new expression in terms of partial fractions, okay? However, you're meant to use the answer to part A, okay? So if you sort of look at this and think, well, I'll just start again, okay, write it as A over and B over and so forth, you'll get no marks at all. You have to use the answer to part A, all right? So how do we go about it? Well, we have to compare what we've got here to what the initial expression was, okay? So I can sort of do that by saying, look, this is equal to, I make a sort of slightly bigger fraction here, okay? And have the same denominator, so x plus 1 all squared x minus 4. But what I can do, I can rewrite this. So instead of saying 5x squared plus 9x plus 9, I can write it as 5x squared plus 7x plus 17, okay, which was what we had initially. And then, obviously, think about what I need to do to this now to get that, right? So if you think about it, 7x here, whereas it's 9x in this expression. So I need to add on 2x, don't I? If that makes sense, yeah? So if I add on 2x, that will now give me the 9x, okay? And the same then, I've got 17 here, but I need 9, okay? It needed to be 9. So in this case, it's too much, isn't it? So what I'll do here is take away. And if I take away 8, I'll get back to 9. So think about this here. Look at what we've got here, okay? I literally put these equal to each other. And with this here, I've sort of written it so that I'm using the expression from A, so 5x squared plus 7x plus 17, and then thinking then what do I need to do to get it back to this? So I had to add on 2x, yeah, to this to get me 9x, and then because it was 17, I had to take away 8, yeah, to get to 9. Now what's good about that is I can now split it up, okay? I can think of this as two parts, so I can think of it as one part and another part, okay? So split it up now, so we've got two fractions. So I get 5x squared plus 7x plus 17 over x plus 1 all squared x minus 4, plus then 2x minus 8 divided by the thing as well, right? The denominator here. So I can split it up. I'm allowed to do that. Now what's great is that this, in terms of partial fractions, we've already answered. So this is where you're using now part A. So we can write that as minus 3, okay, over x plus 1 all squared, plus 5 over x minus 4. And now this, right? Now, what I want you to see here is at the top here, 2x minus 8. We can actually factorize that, can't we? It's a linear term with a common factor of 2. So if I take 2 out and have a single fraction on the top there, think about it. You know, what do I times by 2 to get 2x? Well, that'll be x. What do I times by 2 to get negative 8? Well, that'll be negative 4. So that factorized gives me this. And in the denominator then, you can see nicely that these will cancel, the x minus 4s will cancel, so you're left with this fraction, this fraction, this fraction, and what's even better is we can put the first fraction, let me write it out so it's clear for you, together with the last fraction. So the last fraction there is plus 2 over x plus 1 all squared. So they've both got the same denominator, so I can simplify that. So minus 3 plus 2 is minus 1, so it'll just be minus 1 over x plus 1 all squared, and then plus that last fraction there.